Look at the moon for a second. It's weird how it always shows the same face, almost like it's staring at you. People take that and say the moon doesn't spin. That idea feels simple. It's also wrong. The moon spins. You just never notice because it spins in a way that hides the motion from you. Most people imagine spinning as fast movement, a globe twirling, a toy top dancing on the table. They think spin means fast. They think the moon should be whipping around with craters sliding across the sky. When nothing moves, they assume it's frozen. But nothing about the moon is frozen. The moon turns once every time it goes around Earth. One full rotation, one full orbit. Same pace, same rhythm. A slow turn stretched across almost a month. You're looking at a motion so gentle your brain doesn't register it. If you watched a person turn this slow, you'd lose patience before they even rotated an inch. The key piece is simple. If the moon truly didn't spin, you'd see all of it. You'd watch different sides roll into view as it went around Earth. You'd see the front, then the side, then the back, then the other side. Every month you'd get the full tour. But you never get that. The same face is always there. The only way that happens is if it rotates. Gravity caused this lock. Earth pulls on the moon harder on the near side than the far side. That tiny difference creates bulges. Long ago, the moon rotated faster. Those bulges got dragged out of line. Earth tugged on them. That tug acted like a brake. Over a long time, the moon's spin slowed until it matched its orbit. When the spin and orbit lined up, the tug stopped working. Everything settled into balance. That balance hasn't changed for billions of years. People call the far side the dark side, but that's not accurate. It gets sunlight. It has day and night like the side we see. It just never faces us. When spacecraft finally photographed it, it looked rougher. More craters, fewer smooth plains. The near side and far side formed under different conditions. The moon isn't a uniform ball. It's shaped and scarred by the same gravity that locked it. The idea becomes easier if you stand on the moon in your imagination. Look at Earth from the surface. Earth wouldn't rise or set. It would stay stuck in the same patch of sky forever. The sun would move, stars would move, Earth wouldn't. That only happens if the moon rotates at the same rate it orbits. If it didn't rotate, Earth would drift across the sky. This is the clearest way to feel the idea instead of just hearing it. Tidal locking isn't special to us. It happens everywhere. Most moons in the solar system are locked to their planets. Jupiter's moons, Saturn's moons, Neptune's big moon, Triton, Pluto and its moon Charon are locked to each other. Gravity loves this pattern. If two objects orbit each other long enough, the smaller one almost always ends up rotating in sync with its orbit. The moon is just following the rule. The lock also affects Earth. The moon pulls on our oceans and creates tides. The pull is strong enough to stretch rock by tiny amounts. Most people don't think of land as stretchable, but it is, just a little. The pull also slows Earth's rotation by a tiny amount each year. Days keep getting longer, bit by bit. Nothing dramatic, but it's there. The moon drifts away from Earth about 4 centimeters every year. Slow enough that you'll never notice, still a real effect. The moon used to be closer. Tides were stronger, days were shorter. The whole Earth-Moon relationship has been shifting since the beginning. You're living inside a long, quiet change that's been happening since before humans existed. It will continue long after humans disappear. The steady face of the moon shaped early human life. People used it to track months, to time harvests, to travel at night, to guide ships across the ocean. Ancient stories tied meaning to its shape because it looked the same across generations. Civilization grew around a moon that never turned its face away. If the moon wasn't locked, the sky would have looked different. People would have built different calendars, different stories, different ideas. The moon we know exists because of gravity's slow work. A question people ask is whether the moon could break out of this lock someday. Under normal conditions, no. The forces that hold it in sync are steady. As it drifts away, the lock stays. It would take something dramatic to break it. A huge collision, a major shift in the orbit. Nothing like that is expected. The moon will keep facing us the same way for billions of years. Imagine someone walking in a circle around you while always keeping their face toward you. Their body is turning. It's just synced with their path. That's the moon. It spins. It's just spinning in perfect rhythm with its orbit. There's nothing frozen about it. People think the moon's far side must be pitch black all the time. Not true. It gets sunlight half the time, same as the near side. The dark side nickname stuck because we never saw it before spacecraft. The far side isn't hiding in darkness. We're just stuck on one side of the phenomenon. Something interesting happens because of this lock. The moon wobbles a tiny bit during its orbit. That wobble lets us see a little more than half its surface over time. Not much, about 59%. Still more than people expect. The wobble doesn't break the lock, it's a natural side effect of the moon's path. The locked spin also means the moon has a long day. One day on the moon lasts about 29.5 Earth days. That's the time from one sunrise to the next. Imagine standing in sunlight for 2 Earth weeks, then standing in night for 2 Earth weeks. Life there would deal with long, intense heating and cooling. That's one reason places with no atmosphere get such extreme temperatures. Scientists think many planets around other stars might be locked like this too. One side always in daylight, one side always in darkness. Life could still develop, but it would live under very different conditions. The moon helps us understand what that kind of world looks like. A locked spin changes everything about a planet's surface and climate. People sometimes say, if it spins, why can't we see it turn? Because your brain expects faster motion. You compare it to things that spin quickly. The moon's rotation is paced to match its orbit. You only notice motion when there's a difference between those motions. Here, there's no difference. They line up perfectly. If you could speed time up, you'd watch the moon rotate like a slow clock hand, one full turn every 27 days. It's turning, you're just watching it in real time where the motion looks frozen. This isn't some rare trick. It's the most common outcome of long-term gravity. If a moon orbits for long enough, its rotation slows until the orbit and the spin match. Once they match, they stay matched unless something huge disturbs the system. Nothing huge is coming. The moon will stay locked to us. The same face will keep watching Earth. Same craters, same patterns, same features people saw thousands of years ago. Humans might change. Earth might change. The moon's face will not. The next time you look up and see that familiar pattern, you're looking at the result of billions of years of gravitational shaping. One rotation per orbit. That's the whole thing. Nothing complicated. The moon never stopped spinning. You just see it from the only angle gravity lets you have.